Hello, good afternoon. My name is David Sanana Robert. My metric number is AN190143. Today I'm going to present about the final year project 2 of my hybrid Pico hydro solar fountain for power generation. My supervisor name is Rashida binti Norjali. I'm from the JTKE department in the Faculty of Engineering Technology. The abstract of my project is to create an eco-friendly electrical power generator without consuming any other material, but with only endless running water and sunlight energy using DC motor and solar panel. The prototype of this project aim is to generate 5-volt energy that can charge up to 5-volt battery and be used as a power supply to many other appliances like the Arduino, ESP8266, water pump, LED light, and able to charge up smartphones and many other things that requires 5-volt voltage to be able to charge. As for this project, it will cover the minor daily lives necessity for our daily living need. The system that will be designed and developed will help people to generate electricity for the use of charging handphones battery, provides more light to help us do activities during night time where the sunlight is already gone. The system will also use renewable energy from sunlight during daytime to charge up the electric bank, the battery, and continuous running water to the main supply of the system. So the system is very eco-friendly toward nature. The connection of the circuit and component part can be referred from the findings and will make the troubleshooting of the projects be easier as it can be read from the article of the previous project studies. An efficient way to An improvement of the project will be consisting of a more efficient way of generating power. So there will be lesser power loss and enough potential to support the load that may be implemented on the system. The uses of IoT technology will also be used, so the data of the system can be monitored from the IoT application remotely. This is the hardware of the project, where there is solar panel and the motor, DC motor. This is the system box, where all the Arduino and ESP8266, also the relay module and the LDR is stored. Next is the methodology. For the methodology, I will start with title research and selection. I will choose the best title for my project and then I will research on the previous literature review of past project. From the literature review, I can understand on how to make the project work based on the previous testing of the other previous past project. And then I will design the model of the system. If the model of the system is not good, especially the water pump, I will just improvise the water pump placement. And then if the design is okay, I will straight go to apply the hybrid system that is connecting the hydro, the motor, and the solar panel. And then if the hybrid system is working well, the testing and improvisation will be done. That is where the testing of the connection and the data will be collected and how to improvise the system. The troubleshooting and the data collection was done with using multimeter. The data collected was recorded in Microsoft Excel, and then the data is analyzed. Also, the project is discussed, and then the report making will be started. The result and discussion of the project is, as you can see on this graph, for the solar panel at the medium exposure of sunlight, 5.8 volt to 6.0 volt charging time. The charging time took about 4 hours to fully charge. As you can see on the time here, the voltage remains same, but the speed of the charging becomes slower. The same for the 6.1 volt, 6.1 volt to the 6.4 volt charging time. And then this is the Data of the graph for average voltage and ampere generated by the 12-volt DC motor. The ampere of the motor are higher and exponentially increase by the time. As for the voltage, it is straight line where the voltage only increase up to 0.02 volt on each speed. This is this is by using water pipe, but due to the water pump being weak and unable to spin the motor, the hydropower is functionless in the hybrid system. So the hybrid system of the hydropower is not working on the project. Throughout the project testing and actual, the hybrid Pico hydro solar fountain for power generation has been developed. Some of the functions are not working as expected, such as the function to cut off or open the connection of LED that are being controlled by the LDR. The motor failed to be spun by water current that are being pumped by water pump. The solar panel achieved the objective successfully. These are the reference that I have included. Then this is the video of my project where I can charge the project by using solar panel. It will generate about 5.8 volt to 6.0 volt because of the medium exposure. There is no sunlight that are intense. As you can see, the battery is charged. When it's blinking, it means it's charging. And then the second video is about this is the Arduino system, Arduino programming, and the Blink IoT. I can turn first I will turn on the system by connecting the power bank, and then wait for the ASP8266 to connect to the Wi-Fi. The LDR sensor will detect the light. If there is dark, it will light up. If it's bright, it will turn off. This is the switch of the water pump. If I turn on, the water pump will be turned on. It will start spinning the hydro power, the DC motor. And then for the switch on the Blink IoT platform, if I turn on the LED switch on, it will turn on the LED. If I turn off, the relay will trigger to turn off the LED. That's it for my presentation. Thank you.